Welcome to Next Gen Manufacturing Nexus. Today, we're diving into a technology that can literally sculpt the future out of a solid block of metal. It's called 5-axis CNC machining, and honestly, it's the secret sauce behind creating parts that are so complex, people once thought they were just impossible. So let's break down how it all works.
All right, so just look at this thing. It's called a Blisk, and it's basically the rotor disc and all the blades of a jet engine, all carved from a single piece of metal. Now, how in the world do you make something so complex with all these flowing curves from a solid chunk of superalloy? I mean, you can tell right away your standard drill press isn't going to get you there. Not even close.
And that really is the core of the problem, isn't it? See, conventional manufacturing machines, they just have these hard limits. And when you're trying to make something like a jet engine part or a life-saving medical implant, stuff that has to be perfect, those limits become a huge roadblock. They literally stop innovation in its tracks. So how do we get around that? Well, the answer is all about adding more freedom, more directions of movement. And to really get why that's such a game changer, we first need to talk about what we mean by axes in machining.
Okay, so on the left, you've got your standard 3-axis machine. It moves back and forth, side to side, and up and down. X, Y, and Z. The analogy of a simple crane is perfect. But the 5-axis machine on the right, it adds 2 rotational axes, and that changes everything. It's like giving the machine a human wrist. Suddenly, it can tilt and pivot the cutting tool or even the part itself to get at the material from pretty much any angle you can imagine.
And what's really cool is how they actually do this. There are basically 2 main ways to get it done. On the left, you've got a setup where the tool itself, the spindle, does all the tilting and rotating. On the right, it's the table holding the part that moves around. Which one you use really just depends on things like how big or heavy the part is. But either way, you get the exact same incredible result: total flexibility. So what does all this wrist-like movement actually get you? Well, it's not just a small improvement. It fundamentally changes the entire manufacturing process from the ground up.
Okay, think about the old way with a 3-axis machine. Let's say you need to work on a different side of a part. You have to stop the machine, unclamp the workpiece, physically flip it over by hand, and then, and this is the really tricky part, you have to perfectly realign it every single time. It's incredibly slow, it's inefficient, and every time you touch that part, you're introducing another chance for a tiny error to creep in.
But with 5-axis, you just don't stop. The whole process is continuous. The machine just tilts the part or the tool on its own and keeps on cutting. You can machine almost every single surface of a really complex part without ever having to touch it. It's all done in one go. That's why they call it single setup or done-in-one manufacturing. All right, so this whole single setup thing sounds great, right? But what does it actually mean in the real world? Let's talk about the actual tangible benefits here. Honestly, this single setup process is a total game changer. For starters, it lets you create those mind-bendingly complex shapes we talked about. Your efficiency just goes through the roof because all that setup time basically disappears. The quality gets a huge boost too, because the tool can always hit the material at the perfect angle, which gives you a much smoother surface. And maybe most importantly, your precision is just off the charts. By getting rid of all those manual resets, you eliminate the main way errors get introduced, which means a lot less wasted material. And hey, to put that efficiency gain into perspective, just look at this number: 90%. For some of the more complex finishing jobs, 5-axis can cut the time it takes by up to 90%. We're not talking about a small improvement here. This is a complete revolution in productivity. It literally turns what used to be days of work into just a few hours. So it's really no surprise that this tech is absolutely critical in industries where failure is, well, just not an option. We're talking about aerospace, defense, space, medical, you name it. These are fields that demand a level of precision and complexity that, frankly, only 5-axis machining can consistently deliver. But, okay, all this power and flexibility, it brings a new challenge to the table. I mean, think about it. Moving a tool through 5 different dimensions at the same time is like choreographing an incredibly complex ballet. One wrong move, and it's disaster. So the big question is, how do you control all that complex motion? How do you make sure every single move is as efficient as possible, while also making absolutely sure that your very expensive cutting tool doesn't crash into the part, or the clamps holding it, or the machine itself? Yeah, trying to program that by hand, it's not going to happen. It's impossible.
The answer lies in some incredibly smart software. It's called Computer-Aided Manufacturing, or CAM for short. And you can think of it as the digital brain of the whole operation. It takes that 3D model from the engineer and translates it into the thousands, sometimes millions, of super precise instructions the machine needs to follow to get the job done flawlessly. And that's really the key takeaway here. It's these advanced CAM systems that really unlock the full power of the machine. The hardware is amazing, but it's the software that makes these ridiculously complex operations not just possible, but repeatable, reliable, and most importantly, safe. So what this software does is create a perfect virtual copy of the entire setup, a digital twin. It can run a full simulation of the whole job to catch any potential crashes before they happen. It figures out the absolute best, most efficient path for the tool to take to get the best speed and smoothest finish. It can even predict stuff like cutting forces and how much heat is going to build up, all before a single piece of metal is ever touched.
And you know, this powerful team-up of hardware and software, it's not just sitting still. It's always evolving, always pushing manufacturing toward a future that's way smarter and way more connected.
I mean, this technology has come such a long way. It really started taking off in the 80s for making those tricky aerospace parts. Today, it's all about those powerful virtual simulations we were just talking about. But the future is all about making the whole process even smarter by weaving in things like artificial intelligence and full-on automation. Just think about it. We're right on the edge of having AI that can tweak the cutting strategy in real time based on what sensors are telling it. We're already seeing these wild hybrid machines that can 3D print a metal part and then immediately use 5-axis milling to machine it perfectly, all in one machine, one operation. And the big push now is towards fully automated work cells where robots do everything, which is also driving this huge need to be more energy efficient.
And all of this leaves us with a pretty powerful thought to end on. If you look back through history, every single time we invent a new tool that lets us create more complex things, it unleashes a wave of engineering innovation. So as these machines get even smarter, even more capable, the real question isn't just about what we can make. It's about what we will dream up next. What's the next impossible thing that's about to become possible?